Hi, I'm Philip Whalen. I'm going to be doing the Fluent Bit 3.0 Advanced Routing session today. I am a technical associate at Chronosphere. I've had 24 plus years in software development. I'm an OSS maintainer. I joined Calyptia in mid-2021. I'm an advanced Linux user since about 1998, and I've been exposed to a wide variety of technologies from mainframes to clusters and just about everything in between. So yeah, today we will be learning the basics of Fluent Bit routing, how data is sent from inputs through filters to outputs, how routing is done via tags as well as matches, as well as advanced routing, which is using multiple inputs and outputs, sending data to various backends independently, and the creation of data pipelines without data duplication. Yeah. So what is Fluent Bit? Well, Fluent Bit, the main website is at fluentbit.io. It is a small software that is able to send logs, metrics, and traces using input plugins or integrations from using inputs, then sending them out to outputs. Right? It's very high performance because it's done in C, and because we take care of performance, it's actually capable in many instances of sending millions of messages per second. It is also the default observability agent for various different Kubernetes or K8s deployments, including EKS, GKE, and AKS. It's trusted by millions of users at top companies. It's more than just a simple pipe. It supports transformations, routing, and aggregation, and it's used a lot. It can be used to reduce costs, pre-transforming and dropping information, and it is widely used. There is at least, from quite a while ago, 8+ billion Docker downloads. Yeah. Just a quick overview of what inputs are. Inputs are, well, we have generic TCP and HTTP servers. One of our most popular ones is our file log support with the tail plugin, which supports tail logs, as rotated logs, as well as multi-line through multi-line parsers. Beyond that, we have a lot for very different specific technologies or vendors, including Kafka, and as well as in fact as well, Kubernetes with the Kubernetes event plugin. All the input plugins will take their incoming data format and then transform them into message back. As well, it can be coupled, a lot of these plugins can be coupled with textual parsers if anything else is needed to be able to turn a simple text line into more robust or more complicated structures. And it's plug and play with all the filters and outputs. And so outputs are basically similar. It has generic TCP and HTTP outputs, as well as specific technology or vendor plugins, including Splunk, BigQuery, and all of these work with the same common data structure created by the input plugins. So therefore, it has plug and play with those inputs and filters. And then filters. Usually filters go between inputs and outputs and are used usually to do specific actions, such as modify records, add records to them, filter them, take out and or add keys, as well as rewrite tags, which we'll talk about later, which is one of the things that are used in advanced routing. Besides that, we also have, for when you need something a lot less specific or a lot more complex, we have both Lua and WebAssembly support for filters. And yeah, they work well with both input and output and just sit there in the middle to be able to do any extra processing. So how does it actually work? Well, Fluent Bit has inputs as sources, outputs are the sinks, and filters are used as transforms to transform inputs. They can then be, it can be configured then to more safely safeguard data. Data is promised to be delivered as much as possible. Limits can be set, persistence can be used to persist data to disk in case of outages or restarts. And to make sure that Fluent Bit does not take over your machine, it is possible to have both memory and file disk limits. As well as, like I said before, there's transformations inside with Lua and WebAssembly for complex processing. And we have both inputs and outputs, we have hundreds of different integrations. So as a preamble, let's go into some explanation of how routing goes. So data is received in inputs. You can see here, they're on the right. There are a bunch of examples. One of them is a simple pipeline that is configured in the classic configuration format. And on the right of that one, we have another one that's in the newer format that we're using now, in the YAML format. Right, but you can see there, data is received in the inputs, usually tailing a file, opening a socket, or even connecting out to other services. Then after that, it can be, and I don't think I have any examples there, but it can be parsed through with parsers. That's a separate, different form of configuration, usually using regular expressions or even specific plugins of their own that allow you to parse the raw data into something more usable. This is typically used with things like syslog, where the actual log format, the actual text part will be in some bespoke format that is very specific to the applications. After they go through filters, they are then, according to their routing, sent to several different outputs from anywhere from 1 to n. All right. So like I said before, logs and metrics from multiple sources. You could send specific security logs to separate destinations at the same time, keeping logs. You can send logs to a live log display, right? So that your development people or operators can look at that. Then you can also you can send out production logs to clusters using Grafana or similar, and also at the same time send them to a place for long-time archiving. The same can also be done for metrics as well as traces. And all of this, multiple different inputs and outputs can exist and be configured in a single deployment of Fluent Bit. Another advantage is the possibility of quick testing of alternative observability tools. If you already have a Fluent Bit pipeline set up, it's easy enough to add a different output to be able to test a new type of sync or a new type of system, reporting system, then simply restart Fluent Bit, or even possibly just do hot reload. Send it a hop signal if you're on Linux, and that will automatically reload and restart without restarting the process completely. And then every single new log will be sent to the current output as well as the new one. All right, so to get an idea of what this can actually look like, this is a simple abstraction where we have two input plugins, one that's creating them with tag A and another with tag B. And tag A also has a filter configured with a match straight on the strict word A, that it's filtering anything that will come in from input A. This could be, for example, from one side, it could be a tail log, and then the other one, system D. System D would go to or output B goes straight to the input B goes straight to the output B, and input A goes through the filter and then to output A. It's very simple sort of pipeline. Both of them can be within the same configuration. And in any case, So all data is transformed to the message pack JSON format, right? Internally, the inputs convert to it, outputs convert from it, filters transfer to and from it as well. Each record has a timestamp, a tag, as well as data. Tags are the important thing for routing. In fact, all routing occurs only with tags. And here is, there's a quick example. Right? If we run it very quickly, here's a configuration that is using a dummy plugin and going straight to standard out. Right? We can see here, it's using the tag. The tag, if not configured by using the tag property, it will use the name of the plugin plus a runtime index that is incremented for every single input plugin that is configured in your pipeline. Then after that, it also sends an array with two pieces of data, which is the timestamp in Unix 32-bit, but with nanoseconds in the decimal. And then it also sends the data, which here is being visualized. It's actually sent as a binary format, but it's being visualized with something that's similar to JSON. It allows for arrays as well as key value lists, etc. So it supports natively structured logs, right? And then there's tagging. The tags, which, like I said before, comes before the inputs provide the tags either automatically or by tagging them explicitly. And here are several different examples of how it can be done. Here's just a straight up normal string. This one here, this format uses a wildcard. Well, certain plugins will fill in wildcards or certain parts of the tag with information or metadata that they collect themselves. This one is using, instead of the wildcard, a specific name of metadata that's used to then form the tag. And then the last one here is using a regular expression to do the same. As well as, sorry about that, yeah. As well as the read-write tag, which I mentioned before, is a filter that can be used to then anything that goes through the filter can be both optionally sent to a new tag, or it can be sent both to the new tag and the current tag. So it will just keep on going along in the same way, the data would keep on going along the same way it is, but also duplicated to the other output. And yeah. So yeah, that is just how that's how the messages go out. But the actual matching between filters and outputs to the tags are done then with the match property or the match regex property. It does done, as I said before, they can either do a straight string comparison. It can use the typical match, can also use simple wildcards, or it can use a full match regex, which allows full regular expressions. The specific syntax used is the one used by Onigmo, which is a Ruby library. We do that because of maintaining compatibility with Fluent D. And by the way, yeah, strictly speaking, it's not a good idea to mix and match regex in the same configuration section. Mind you, I did some quick tests. It does not seem that it has any problems where messages won't be routed or dumped or won't be duplicated, but I would say that you cannot rely on that behavior. By the way, there was a question. I'll take it very quickly because there's not much to say, but yes, Joshua asked, will the session go over TLS SSL configuration? And no, unfortunately, no. That would be more of a talk on networking. But I think I'll recommend to Austin if we can look into something that would specifically cover that, but can't make any promises. Yeah, so here I'm going to go over a couple of routing examples. They're just going to be at an abstract level, and just to get an idea. There's multiplex matching. Filters match in order they are defined in configuration file. This is a single configuration here where we have two different input plugins, but one of them has a filter that's only applied to itself. Another shared filter between both of them, and then two outputs where one of them is only used on one of the inputs and the other is used on both. You can see input A here will go through first the filter 1 because of a straight match. Then the wildcard will match both the input B as well as input A. And then after that, any remaining messages that get through filter 1 and 2 from input A will show up out output A, and any from input B will go to output all, as well as any from input A will go to output all as well. So yeah, this is a very typical kind of configuration, especially when you have data that you need to store both of them, but certain data has to be prioritized because it's necessary to see it online or something of the sort. And yeah, and then here, just going to go over pretty quickly again what the rewrite tag filter does. It allows you to, once it hits the rewrite tag filter, according to a rule, it will be able to then say whether or not you want to. It uses regular expressions. It uses a rule syntax, which it can be found in the documentation, where it will match on a key with a regular expression. And then a fourth flag will say whether or not it will continue on, a copy will continue on where it is in the same flow, or if it will only send the message that is being sent to the new rewritten tag. Under the hood to do this, what we are doing is using a transient version of a plugin that is not actually accessible and configurable called input emitter. And so, yeah, it will be emitted by this other plugin. So yeah, that has also other consequences, which means that you're not able to specifically configure for storage or any other sort of thing like that. But in any case, you would usually tend to configure the base plugin where you're rewriting the tag anyways. So yeah. Yeah. They're asking here, Chris Weinhobel. Yeah. No, multiple tags are not possible. Usually what you'll want to do if you want to do multiple tags. So yeah, you can't tag messages with multiple tags at the beginning, but you can actually do the same functionality with rewrite. What you would do if you wanted to have those 3 tags is that you would have, for instance, input B in this case, and it has a single rewrite filter. You would just run it through 2 rewrite filters, and you would keep it in both cases. And then you just have it tag 1. Then you would have a rewrite filter that adds tag 2, and then another rewrite filter to add tag 3. That would give you the same functionality. So yeah, any more questions about rewrite? About that? So yeah, here another example. This one is very typical. It's an example where we have 2, we're going to go through some various examples, just start with this, but yeah, basically having a tail, using a tail input plugin to be able to tail Kubernetes logs, then using a filter on it called Kubernetes. This Kubernetes filter, what it will do is it will extract, what you do is you configure the tail plugin, the wildcard, so it grabs the path and sends it as part of the tag. Right? As you can see here, it's using the asterisk. That means that, yeah, that asterisk, that wildcard will, depending on the input plugin, be filled in with extra information or metadata. In this case, it will send in right here. Yeah, it will send a version of the path, but using dots instead of slashes. And then the Kubernetes filter will extract extract the information from the tag to be able to then use authentication and other things like that. It will then connect to the Kube API, and it will grab the annotations and labels, and it will then insert the annotations and labels as part of the structured data. Right? And in this example, you can see that they're doing both that. It's going to enrich that information because that's applicable to the Kubernetes logs. And then it grabs the logs from system D. It tags it separately so that both can be identified easily using a wildcard that just uses host.asterisk or kube.asterisk, so you can identify between either. And then, yeah, it just fires them off. Yeah, and this is actually used by some of our own Helm charts. Yeah. So yeah, just to go a little bit deeper into the Kubernetes filter behavior, as I said before, yeah, the kubit logs always include basic information, the namespace, the pod, the container names, and information like that. The tail input then encodes part of that information into the tag. And then the K8s filter, the Kubernetes filter I was talking about, that can use that to be able to grab the other metadata associated to that pod. That way, for instance, you could be able to use the labels to be able to identify different environments that they're deployed to or as well as annotations. This could possibly be used to be able to identify what version or what team, what release, things like that, depending on how you're using annotations in your organization. They can also be used because they are inserted into the records as more data as part of the structured records. You can use them in further filters to be able to either rewrite the tags so that they go in parallel or different pipelines, or you can also use them to do other logic to be able to filter them and things of the sort. So yeah, we're taking that same example. You can see here, for instance, if we had, this is an example, for instance, you were using Loki to be able to look at logs online from Kubernetes, but you wanted to be able to save all your system D logs as well as your Kubernetes logs, and S3 for long-term archiving and storage, right? You just have the simple input, both inputs. The filter matches based upon cube.wildcard. It will be filled in by the input, but in this case, it's only used as a match for the filter. And then after that, it's the only one that's being matched on the output, but both are matched on S3. So your S3 would store all of your logs, but the Loki ones would only be showing you your Kubernetes logs, which is probably what you would be wanting to see to make sure that your pods are working. As well, you can take the same one. This is how you would add one, right? We'd have the same one is going to Loki. And then after that, right, when you already have this one, you just add a new output. It would be the same. You just have your configuration file with one output before you add the other output, and then you either restart Fluent Bit or do hot reload. And now you'd be sending your records to OpenSearch. If you had the other output to S3 as well, you could at the same time open OpenSearch as a third output. That way you would be able to search all your logs, all of your logs online in OpenSearch, be able to look at them quickly in Grafana. And if you still kept the S3 output, you'd still have your long-term archival. And yeah, this would be a good case scenario if you were evaluating whether or not you were going to add or switch from Loki to OpenSearch. As well, targeted out. Here's another example, targeted outputs. This using both two pipelines, a pipeline that is running logs, as well as now we're adding a new one that uses metrics. So yeah, metrics uses more or less the same syntax. There are certain plugins that use logs, certain others that do not. But for instance, in this case, we're using the node exporter log, which is a C version that gathers the same statistics, the same metrics as node exporter from Prometheus. So we just port it over, use most of the same statistics, and that is being sent to Prometheus exporter. So then, yeah, you could then have a Prometheus exporter added as a, yeah. Oh, give me a second. Yeah, I'm going to take a second here to answer a question. Can you get your pod logs apart from varlog containers? Well, in the case of varlog RabbitMQ log, you could simply just change the path. Yeah, you could simply, two things you could do. If you have access, if you're running Fluent Bit and it has access to varlog RabbitMQ, you could simply change the path so that it's reading those logs. If you were doing it in Kubernetes, there is, that's the easiest way to do it. There was work on, but I'm not sure if it's done yet. One that would allow you to grab the Kubernetes logs straight from the Kubernetes API, but that one isn't out yet, as far as I know. But yeah, in any case, yeah, there's, as long as you can actually access from the Fluent Bit, if you can access that path, then you can get it. And one way to do that, if you're running it on Kubernetes, you could simply just have a daemon set that has different pods that are running Fluent Bit, that then on each one of those pods accesses that, and then you could hard code a filter that makes sure that it adds, you just hard code a filter that adds a record with record modifier to then add a record, or yeah, with a property that adds the node, the specific node, in case you would want to know from which node you're gathering the statistics. But yeah, that would work. First way to specify, is there a first class way to specify namespace containers for forwarding from Kubernetes? Yeah, the namespace can be derived from the Kubernetes filter. So in case you wanted to then redirect it, you could do a rewrite tag after the Kubernetes filter, if that's a way that you want to be able to differentiate where your traffic is going based upon the namespace of the container. Yeah, does that answer your question? Yeah, you can actually testing configurations. If you only need to test the syntax as well as, I'm not sure if it does a initial init test, but if you just need to test that the syntax is correct and you have all the right properties and stuff like that, you can use the --dry--run option. We're just running it from any version of Fluent Bit, of course, that will have the same plugins as what you're running in your container. And you run it, then after that, you just add a -c with the configuration file, and it should do a dry run of your configuration. It won't do all runtime tests, but it will at least test to make sure that your properties are all the right ones, that you have the right configured plugins and all that. Yeah. So yeah, I'm gonna quickly go through it. So yeah, as I said, this is the most complex one, but a single, as you can see from the example here, don't have a concrete example, but this does work out if you put it into an actual, if you just concatenate all these. So working in configuration file, you can see that in a single deployment of Fluent Bit, you're able to do in parallel both logs and metrics from a single configuration. Yeah. And then, the last slide, I just wanted to talk really quickly about processors. They don't necessarily directly have anything to do with routing, but they can be used to alleviate some of the problems that are caused by using filters. Inputs and outputs now, since version 2.2, are possible to run as threads and outside of the main thread. So you have to use threaded on specifically because it's not run in, none of them are run by default as threads. You put threaded on and allow you to run your inputs as threads. They'll use ring buffers to be able to submit the messages to the main thread. And then using the workers property on output plugins, you can run those as workers, which are run by threads. And in this way, you're able to alleviate load, or you're able to scale up with different things. But until now, all filters have run on the main thread. There was no way yet to be able to change them out or anything like that. So in case you have problems with starvation or anything like that, you can run threaded on and you can run all of your filters, most of them, not all of them. Rewrite tag is still not a processor as far as I know, but the rest of them are usable. It's actually, I may be wrong about that, but I'm not sure about rewrite tag. But the rest of most of them and some specific plugins can run as processors. That will allow them to run in the input or output thread. And that also can be used on outputs to be able to add extra tags to your structured data, etc. This is in case only available in YAML configuration, but yeah.